Hello.
Hello, sir. Good
Yes, sir.
evening.
Good
Yeah.
evening.
Am I audible?
Yes.
Yeah. Okay.
Yes, sir.
So very good evening to all of you.
Good evening, sir.
Good evening, sir.
Good evening. Good evening. Okay. So we will start. We will cover the week 5 and week 6.
Yes, sir.
We will cover each topic. So just let me, if by chance any topic is some left out, but we will try to cover each and every topic. Okay.
Okay, sir.
So let me share my screen. Okay.
Sir,
Yes, please.
yes, sir. This is Devsina, sir. Before starting, I would like to have some information
Yeah.
regarding. So in week 6, there was two parts of assignment. Part
Mm-hmm.
one was the thing we were doing earlier, but part two was some EMQ. And then
Yes,
there
yes.
there was a simple pattern given on which we have to answer the questions. So I
Mm-hmm.
did that, sir.
Yes,
And
yes.
actually, I was doing my assignment through my phone. I was outside, and I submitted it by writing it on note and then taking it as and choosing the file from there. The option given, but so
Okay.
there was keyboard error and anything, and my assignment was submitted, but result was not displayed. And I
Mm-hmm.
posted it in forum twice, thrice, and mail
Mm-hmm.
also, but no response is given to me. So, sir, I'm asking if it is not submitted or there is no score calculated,
Mm-hmm.
uh, and I have applied for all the courses as I passed the qualifier,
Okay.
my CCS. So, will I be able to give this internal and end-term exam?
Yeah. See, due to one graded assignment, I don't think there should be not effect. According to your I think grading pattern of week 6
Best
to
of
week
nine. Best of
best
nine.
of 9, right?
Yeah.
No, no, not 9. It should be total is there 8, right?
Yes, sir.
One second. Yes, you can see from here there is some grading pattern.
No, sir. At first, in first week, there was in the first month, before the qualifier, there was key we have to submit each and every assignment. So that's why I'm asking. I have submitted my assignment, but it was not calculated. So it will be a problem, or it's okay because
Okay,
I
we'll
know
check.
that now
We'll check.
semester.
We'll check.
Okay.
We'll check. No worry
Yes, sir.
about it.
Please post your query
Yes,
and
yes.
please help me out
Yeah.
with this.
Okay,
Thank
okay.
you, sir.
We will check.
Thank you, sir.
Excuse me, sir.
Yes.
Sir, since only 20 participants are there, I want to share something with you that I am
Mm-hmm.
facing. Sir, I'm facing issue with permutation and combination, and I
Mm-hmm.
can't able to solve the question. I can solve the EMQ questions, which you have done with, I think, solve with a session. And
Mm-hmm.
I think 60-70% questions are correct and else are wrong. And when we move on to numericals, I think I visualize it wrong every time and got wrong answers, and due to
Okay.
this I'm lacking behind in probability also. The questions which doesn't involve PNC, I solve it
Mm-hmm.
with 100% accuracy, but when it comes to PNC included questions, I'm doing the errors, sir. So what can I do and how can I improve? Because I have
Okay. See.
practiced many questions, sir, as you have mentioned in last week,
Yeah.
but
Listen
still
to me.
I'm
Listen to
facing
me.
issue.
In permutation combination, what is the main issue? If you are trying to use formula directly, then it may no reach
And sir,
problem.
basically visualization में issue आ रहा है.
Yeah. Visualization issue must be clear, and you must be clear like how many cases should be there or whatever. If you I don't if you are clear to EMQ things, I mean, if you read the question, you know what is the simultaneous, if order matter or non matter, if there is without replacement or with replacement or not, then I don't think you should face problem whether to use. You see, if you know events are simultaneous, if you know with replacement or without replacement, if you know order matters, if you know there is order matters, then you have to use permutation. If you know there is order doesn't not matter, then you have to use combination. That's it.
I
Okay,
don't know,
see.
sir.
Okay,
Only
see.
60
Okay,
70% are right. And
no worry about that. We will
I,
cover all the topics of week 5 and week 6 today.
I,
We will revise this is the revision session kind of things. So, and we will solve some
And
questions
sir,
also.
I am focusing too much in this permutation and combination. I am lacking behind in other subjects due to this. I wasted whole, I think 1.5 days on it. I still can't
Uh,
able to do it. I don't know
okay,
what is the main
I
problem, sir. So just sharing with you.
okay, no worry. I can only say like just do practice and all things. Okay, let's do today's session. We will cover all the concepts, all the topics of week 5 and week 6, and we will do some questions also. After that, if you feel any problem, then you can ask. Okay.
Sure, sir.
Okay. So this is week 5. We can finish. If you see in week 5, there is counting principle concept, right? You all people are familiar with the counting principle things, right?
Yes, sir.
Okay. Suppose any event A, okay, is occurring in n1 different way. Okay. It can be any event, and another event B is occurring in n2 different way. Then suppose what will be the total number of occurrence of the I mean xn A or xn B? What will be the total number of A's? Any people?
N1 plus N2.
N1
plus
N2.
Okay. So what is this? This is something addition rule of counting. You can, right? Am I right?
Yes, sir.
Yes, sir.
Okay. Let's
But,
take a example for this. Suppose a event A is says. Suppose you have choices of 4 different laptops. Okay. Suppose you have choices of 4 different laptops. Say L1, L2, L3, and L4. Okay. And event B is something. Suppose you have, let's take 5 choices of what can be. You can take like writing device. Okay. Any writing device. That means W1, W2, W3, W4, and W5. So I'm saying, what will the total number of occurrence if you have options? You can choose either a laptop or a writing device.
4 plus 5.
4 plus 5.
5.
That means, see, what is this? You can choose laptop 1 or laptop 2, 1 way, 2 way, 3 way, 4 way, 5 way, 6 way, 7 way, 8 way, and 9 way. That means what? 4 plus 5 equal to 9. That means this is
Your voice is not coming, sir.
right?
Hello. I have doubt.
Yeah, yes, please.
Actually, you are based on this whether either or. Only this is the only criteria, or you have to put some logic behind questions.
No. See, logic is this. So
voice is not clear.
Yes, sir, your voice is lagging.
Okay, now am I audible?
Yes, sir. Yes.
Okay, I'm saying, suppose you have any event A, right? Okay. And event A, I mean, this event can occur in n1 different way, right? And you have any event B, which can occur in n2 different ways, right? Then what would be the total number of ways, I mean, for the occurrences of the event A or B? Just you have to count the both ways. I mean, n1 and n1 plus n2, right?
Yes, sir.
Okay, that is there. Suppose you have event A, that means where you have to choose. I mean, you have options of 4 laptops, and event B, you have choices of 5 writing devices. Okay. Suppose I'm saying, what will be the total number of ways in which you can choose either a laptop or a writing device? Then what will be the total number of ways? 9.
In lecture, he also told this some sort of dependency between these two, A and B.
Dependency means what?
Whether A is dependent on B or B is dependent on A. Based on that, you have to decide whether what principle you have to apply.
Oh, see, that is the another thing. I'm just trying to explain the addition rule of counting. Okay.
In addition rule itself, he told.
Okay, suppose I'm taking the example of ma'am. I think there was some example of 4 shirts, right? If I'm not wrong, and 3 pants, right? Okay. There was a gift card, and you have a choice of you can buy only one item, right? Then in how many ways you can buy an item?
4-way shirt and 3-way
Seven.
7 way.
7 ways.
That is the same thing.
Okay.
Okay. Got it?
No.
Okay. This is the something, and you can generalize it. You see, even event A, B, there can be an event, right? Okay. For 2 events, there is addition rule of is what? N1 plus N2. Right? Suppose instead of two actions, I have n actions. Then what will be the n actions of suppose r actions? Then what will be the total number of this?
N1 plus N2 up to NR.
NR. That's it. Right? What is this? This is nothing but the addition rule of counting. Right? Now, let's move for the multiplication rule of counting. Okay? What is multiplication rule of? Suppose that example, shirts and pants example. You had 4 shirts and 3 pants, right? Now, suppose I'm saying you can choose either, you can choose 2 items. I mean, 1 shirt and 1 pant. Okay. Then in how many ways you can choose?
4 into 3.
4 into 3, right? That means 12. You can see you are applying the direct formula. That means what will be the total visualization? Like it can be shirt 1, pant 1, right? Shirt 2, pant 2. Let's take shirt 1, pant 3, right? Okay. Similarly, it can be shirt 2, pant 1, shirt 2, pant 2, shirt 2, pant 3, right? Similarly, I can do for shirt 3. Similarly, I can do for the shirt 4. How many ways are there? 3, 3, 3, 3. That means what is that are nothing but 3 into 12. Are you getting my point? That means what is concept? That means you have to choose a shirt and a pant, not a shirt or a pant. You have to choose a shirt and a pant. Is it clear to everyone or not?
Yes, clear.
Clear, sir.
Okay. See, that is the same thing. Suppose this is the action A and this is the action B. Okay. And number of ways for occurring action A is N1 and for action B is N2. Okay. Right. Then in how many way I can choose, yeah, or you can say like total number of ways occurrences for the actions A and B together. What will be the total number of ways?
N1 into
N2.
N1 and N1 into N2. That is the same as the previous example. That means 4 into 3. Is it clear? What is the concept?
Yes, sir.
Right?
So here we
that
can
means,
make a tree diagram also.
Sorry?
We can make a tree diagram also.
Yeah, you can approach. See, you can make tree diagram, and for if you go in what
Or a table.
probability kind of thing, there you can make Venn diagram also kind of things. The approach
Okay.
are it's individual. It depends on individuals.
That is
And,
based on
yeah.
familiarity. Okay.
Yes. And some people, starting to solve the questions by counting the things. Some people who are kind of expert, they are starting to apply the formula direct kind of things. It's individual choice.
Sir, can we,
So yeah,
sir, can
it's
we say for simultaneous event we apply multiple
and yeah, and
and
for non-simultaneous there is or.
addition rule?
Yes, okay. Because see, non-simultaneous, suppose I'm saying events A or B, right?
Yes, sir.
That means for this you have how many ways? N1 plus N2. That means actions A or action B. I'm not talking simultaneous. I'm saying either this or this.
Sir, all time we
That's
see
why it's non-simultaneous.
only simultaneous examples. Can you give me more
Yeah, maximum.
complicated example of this non-simultaneous event?
Okay, let's see. Okay, we will see. I mean, let's move for first.
Okay.
Okay, to the 6th week, we will cover. Okay. Okay. So till now it's clear. What is the multiplication rule? Okay.
Yes, sir.
Suppose that previous example, laptop, 5 laptops. Okay. Sorry, it was 4 laptops and 5 writing devices, right? Suppose I'm saying you have to choose one laptop and one writing device. Then how in how many ways you can choose?
4 into 5.
4 into
20
5.
ways. 4 into 5 ways, sir.
That means 20 ways. Because here you are not counting separately. You are counting. You can choose laptop 1, writing device 1, laptop 1, writing device 2, laptop 1, writing device 3, up to writing device 5. Okay. Similarly, you can choose laptop 2, writing device 1, and so on. Laptop 2, writing device 5. Okay. You have to choose laptop 1 and writing device 1. That means you are choosing one action. I mean, you are doing one action and the another action. That means occurrences of the first action and number of ways occurrences for the second action. Is it clear?
Yes, sir. What if we choose 2 laptops and 1 writing device?
That, see, number of ways will be changed. That's it. Okay, if you are choosing 2 laptops, then you have to options 4C2 and kind of things. Okay, if you have to choose laptops and you have to arrange somewhere, then you can choose 4 into 4C2 and you can arrange in 2 factorial ways. You can proceed further. It will depend on the objective of the question. Okay.
Okay, sir.
Okay. Suppose instead of 2 actions you have R actions, then what will be this is nothing but N1 into N2 up to NR. You have to just multiply the R actions, occurrences of the R actions together. Till this point, it's clear to everyone?
Yes, sir.
Okay. Now, let's move for the factorial things. Okay. What is factorial? Anyone?
Factorial is a product of positive integers.
Number of ways we can arrange.
From n to 1.
Yes. See, factorial nothing but you can say product of the someone says product of the n positive first and positive integers. What is that? Suppose I'm saying n factorial. That means n into n minus 1 into n minus 2 into up to 3 into 2 into 1. Right?
Yes, sir.
This is the
sir.
concept of the factorial. Suppose I can write n into n minus 1 into n minus 2 factorial. Can I write?
Yes.
Yes, sir.
Okay. I can also write n into n minus 1 factorial. Okay.
Yes, sir.
Because from here, if you see from here, things are what? Things are getting, I mean, things are nothing but the product of the quantity subtracted by 1, right? What is the quantity from here? This is the is nothing but n minus 1 into n minus 1 minus 1 into n minus 1 minus 2 and up to 3 into 2 into 1, right? So I can write this is as the n minus 1 factorial, right? Are you getting my point?
Yes, sir.
Is it clear to everyone or not?
Yes, sir. Yes, sir. Yes, sir.
Clear,
Okay.
sir.
Yes, sir.
And by convention, you know what is the meaning of 0 factorial? 1. What is the value of 1 factorial is? 1, right? This is the nothing but in the factorial is covered. I think week 5 is in week 5 these only these two topics are there, right?
Yes, yes, sir. Yes.
Yes, sir.
Next
Okay,
permutation comes 6.
Sorry? Yeah, permutation and combination is from. So any doubt in this syllabus of week 5 or any question from week 5, if you have, so you can ask. Otherwise, we will move for the week 6.
Sir, the problem is we understand the concept, but when we solve problems, we get
You
stuck
get-
in between.
Yeah. Okay. That was the
Yes,
problem.
sir. The main problem is the visualization part. As I have interrupted you, if you to choose 2 laptops and one writing device, what will be the visualization? Because when we see the solution, we can understand, but
See,
at the time of solving, it's confusing.
Okay. First thing, you have to be clear what is the statement of the question. Okay. Suppose, see, you have to, if you are starting in the permutation and combination, then you must see what my suggestion is. Start writing the, from
Criteria.
initial.
Yeah, what is provided.
Suppose I'm saying I have 4 laptops, right? And you
Yes, sir.
had 5 writing devices, right? Then suppose I asked question, you have a coupon and you can choose a laptop, either a laptop, okay, or a writing device, right? Try to understand. I'm saying you have a coupon or you have a criteria, whatever you can say, in which you can choose a laptop or a writing device. Okay. Then it question, in how many ways you can use your coupon. So what is the question? Question is you can choose either a laptop or a writing device. That means I can choose either a laptop 1 or laptop 2 or laptop 3 or laptop 4 or writing device 1 or writing device 2 or writing device 3 or writing device 4 or writing device 5. That is okay. That means I can choose. I have these all the possible cases. Okay.
Yes, sir.
Right. So what is the question? Question is you can choose either this or this. Okay. Either a laptop or a writing device. That means how many ways you have? You can one way, 2 way, 3 way, 4 way, 5 way, 6 way, 7 way, 8 way, and 9 way. Right?
Right, sir.
So be clear what is the question asking to you. Suppose instead of R, I'm saying you can choose a laptop, okay, and a writing device. Okay. Then what is this? A laptop and a writing device. That means a laptop and a writing device. You got what is the difference?
Sometimes it is not clear in the questions actually whether it is either or and. In that situation, how can get out of the what's
it's depend on the question. Okay, just tell me what is the question we will discuss. Okay, just tell me. So you are getting my point. What is the yes, please?
Sir, in your question, that you're saying that we are selecting laptop in 4 ways, or we are selecting writing device in 4 ways. So here we are talking that we are selecting something in 4 ways, means in 4 factorial ways. 4 factorial.
No. What? That is not. See, what is the 4 factorial? What is the n factorial?
N into n minus 1, n minus 2, and so on, up to 1.
Okay. What is the meaning of 4 factorial? That means you have 4 things, okay? and you have 4 different places, and you have to arrange these 4 things at the 4 different places. Okay, suppose I'm saying I have 4 laptops, right? 4 different laptops and 4 laptop bags, suppose. Okay, this is bag 1, bag 2, bag 3, bag 2. Then what, suppose I'm asking, in how many ways you can arrange these 4 laptops in these 4 laptop bags? Then what will be the number of ways for the first bag? In how many ways? I mean, you
4
can
ways, sir.
put any laptop out of 4 in the first bag, right? Clear or not?
Yes, sir.
Now, and see, I'm saying you have to fill all the laptops in all the 4 bags. Okay, then you fill the first bag and you have to fill the now second bag. Then one laptop is already filled in the first bag. Then in how many ways you can fill the second bag?
3 ways.
4 minus 1, 3.
3
Because
ways.
you can choose, you can take any laptop out of 3, right?
Yes.
Similarly, what will be the for second bag?
2 and 1.
What will the, that is the 4 factorial. Okay, so
Still
be
not
clear.
getting the difference between that, sir, previous question and this 4 factor.
So previous question what? Previous question, I'm saying you have 4 laptops and 5 writing devices. Okay, and suppose you have a coupon, and in the coupon condition is that like you can purchase a laptop or a writing device. Okay, that means you can purchase only one item, or a laptop, either a laptop or a writing device. Then I can see, I can purchase any of the 4 laptops or any of the 5 writing devices. That is the 9 way. I'm not saying you have 4 laptops and you have to arrange the things. Okay.
Here in terms of
see, this is just some, this is just counting, and that's all. Is it clear or not?
Yes, sir.
Okay.
You can move it.
Okay, so let's move.
Sir, I have one more question.
Yes, please. In week 5.
In activity question 5, question number 2.
Activity what? 5.1,
5.1.
This question number 2.
Yes.
Yeah. What is your doubt?
I do not understand the question.
Okay. What is the question? There are 13 flights from Delhi to Bangalore, right?
Yes.
Let's write the things. Delhi to Bangalore, you have 13 flights, right?
Yes.
Okay. And then 6 flights from Bangalore to Chennai, right? Bangalore to Chennai, you have 6 flights. Okay.
Yes.
Now, Riddhi wants to fly from Delhi to Bangalore and then to Chennai, right? How many choices does she have for her flight plan? Okay, tell me. Delhi to Bangalore, then to Chennai. Riddhi wants to fly from Delhi to Bangalore, okay, right? And then to Chennai, means Delhi to Bangalore and Bangalore to Chennai. Then how many choices she has?
13 into 6.
That's it. That is the correct answer.
Yes.
Right? You got? See, here
yes,
is
yes,
what? You have event A, that means Delhi to Bangalore, right? Choices for this event is N1 way, right?
Yes.
Okay. And you have action B or event B, whatever you can say. And for this event B, you have N2 choices, that means 6 flights. Okay. You have, see, what is this? She wants to go Delhi to Bangalore and then to Chennai. Not I'm saying she wants to go either Delhi to Bangalore or Bangalore to Chennai.
Okay.
Is it clear to everyone?
Yes. Yes.
Okay. Okay. Let's move. Anyone else? Any doubt from week 5? Any question and all things we can discuss also. If you have doubts, then we can discuss.
This is the last question actually.
Sorry?
5.1 last question. There is something hidden. Solve
This one?
How many?
Yes. This fourth one, right?
Okay.
In how many ways can a number be chosen from 1 to 20 so that it is multiple of 2 or 3? Okay, just count 2.
2 or
what
3.
Is the,
okay.
What is the multiple of 2?
Multiple 2, 4, 6, 8.
No. You have to choose 1 to between 1 to 20. Okay?
20, sir.
So it will be 2, 4, 6, 8, no, 10, 12. See, okay, 14, 16, 18, right? And 20 also. That means 3, 3, 6, 9, 10 is 10 numbers.
But
10 ways
question
possible.
in between. In between, it means you have to include 20 also.
See, question is what? From 1 to 20, not between 1 to 20. Okay. So you have to consider 1 to 20. Okay. Similarly, you can do for the 3. What will be the 3, 6, 9, 12, 15 and 18. You cannot take 21 because you have to choose 1 to 20, right? Then what is the number of ways? 6, right? Be careful. There is 2 things which are common. Okay. So you have to subtract. That's it. There are 13 ways. Right?
Common part.
Yeah, common part you have to do. Okay. Okay, let's move for the week 6. Okay. Now.
Excuse me, sir.
Yes, please.
In graded assignment 5, I have a doubt in question number 7, sir.
Graded assignment 5. Okay, so have you gone through the solution PDF?
No, sir.
Okay, just go through the solution PDF. You will get a clear idea. Okay.
Oh, okay.
Okay, just tell me what is your doubt.
Two students watched a patriotic movie. An analyst wishes to ask each student whether they like the movie or not.
Yes. Okay. And
so in that case, we have to take the 3 cases to answer, to refuse, and again they are going for liked or not. There is a confusion in the question, sir.
Yeah, no, not confusion. See, what is the question? In the question, it is mentioned each student can either answer the question. That means each student can either answer the question. That means each student has 2 options. Answer the if
whether they like it or not.
Yeah, if students are answering the question, that means he will answer it whether
yes
or
no.
Like
yes
or not.
No.
Yes, sir.
2 way or refuse to respond 3 way, right?
Okay.
Okay. Then
okay.
Each, I mean, in how many? I mean, you will have some different data, but for me it's 8, so it will be 8.
Yeah, for me it's 2 students, sir. Okay, it's okay.
So,
it's okay.
Clear? It's clear?
Yeah, it's clear, sir. Thank you.
Okay, so in week 6, there is concept of permutations and combinations. Okay, we will cover all the topics of permutation combination. Okay, now what is a permutation? See, permutation is nothing but permutation is an
arrangement.
You can say arrangement is there, but ordered arrangement. Okay, permutation is what? This ordered is nothing but the ordered arrangement. That is the difference between combination and permutations, right? Ordered arrangements of all, or you can say some of the, yeah, you are right. Some of the n objects or R. Okay. See, so if you're talking about the permutation nothing but the ordered, because order is better in the permutation, right? Okay, if the things are occurring, I mean, suppose I'm saying you have to do the arrangement in without replacement. Okay, you know the meaning of without replacement or without repetition is same, right?
Yes, sir.
Okay, suppose I'm saying you have to do the without replacement. That means in how many ways you can do? I mean, you can arrange the Suppose R objects out of n objects.
Without repetition.
Yes, without repetition.
NPR, sir.
NPR.
Okay. Why not n raised for R?
Because that is for with repetition.
Yes. Without replacement means, suppose I have initially n objects, right?
Yes,
okay.
Sir.
And out of this n objects, I want to do the permutation of R objects, right? Permutation of R objects means I want to arrange the R objects kind of things. Okay. You can say I have to arrange the n things at the R places. Okay. Now, for the first place, in how many ways I can arrange?
N
times.
And for the second place, how many ways we have?
N minus 1.
N minus 1.
For the third place,
N minus 2.
and so on. And for the last third,
1.
3, 2, 1. What is this?
It's factorial n.
This
N
is the
factorial.
n factorial. No, wrong. Strong. This is the something n factorial. You have to arrange n objects at the n places. Okay. For the permutation of R objects and at the n places, what will be this? N
R factorial.
N minus 1 and n minus 2 for this is for the first place, for the second place, for the third place. So for the rth place, it will be what?
N minus R plus 1. N minus R
N
plus
minus
1.
R
plus 1.
Yeah. If you this is same as n minus R plus 1. Okay. So what is this? This is nothing but the formula of, see, if you have n into n minus 1 into n minus 2, okay, and so on, n minus R plus 1, right? Okay. Now, can I write this equation like this? N minus 1, n minus 2, so on, n minus R plus 1, n minus R, n minus R minus 1, and so on up to 3 into 2 into 1, right? Divide by, if I multiplied by this quantity, then I have to divide by this quantity as also, right? Okay. So tell me, what is this quantity? N factorial? This whole thing.
Yes, sir.
Yes, sir.
And
N
what is this?
N
minus R factorial.
What is this thing?
NPR.
Is it clear?
Yes, sir.
Okay. And if you apply the formula, I mean, if you use this formula, then what will be the value of NP0?
1.
1. Okay. So what is the meaning of this NP0? Anyone?
Yes, sir.
We have to choose 0 items out of n.
Arranging 0 objects
Arranging
out
0.
of n.
Yeah, sorry. Arranging 0
1 second.
objects out of n.
Yeah. What is that?
Arrangement of n.
0 objects.
No. Arrangement of n ordered object out of 0.
No, sir. Arrangement of 0 objects.
Arrangement of 0 objects.
No arrangement.
Yes. No, you can't say no arrangement. You will say there is only one way for the arrangement of, or you can say ordered arrangement of the 0 objects. Right?
Right, sir.
Okay. Suppose what is the value of NP1? It will be n factorial divided by n minus 1 factorial. That means n minus 1. It will be n into n minus 1 factorial. N minus 1 factorial equal to n. So what is the meaning of NP1?
Ordered arrangement of one object.
Sir, I have a question here.
Yes.
Sir, NP0, ordered arrangement of 0 objects out of an object. How can we arrange 0 objects?
See, no. It's a meaning. See, try to understand the meaning of this. This is nothing but there is only one way for arrangement of the 0 objects. Right? Suppose you do not have any objects, then in how many way you can do? One way.
One way.
There is one way you can't, like you can say you can't do anything for simplicity, right? That is the
okay.
And for what is the meaning of this? There is, or you can say there are n ways for arrangement of the one objects.
So can you take some examples, sir, to explain, like take some objects like that and something? So
sorry,
can you take some examples, sir, like taking some object?
Okay, let's take
combination like that. I mean permutation. So
okay. Suppose let's take the example of 4 sets. Okay, previously. Okay, suppose I'm saying in how many ways and see you have 4 sets and you have 4 bags. Okay, suppose you have 4 bags. Then suppose I'm saying in how many ways you can fill the, or you can say, yeah, you can say you, in how many ways you can fill the one set out of 4 sets.
First time I have 4 combination. I mean 4 option.
See, you have 4 options: set 1, set 2, set 3, set 4, right? Yeah. You can fill any of the 4 sets in the first bag.
Yeah.
That is the 4 way. That is the
correct. Yeah.
That is the meaning of 4p. That means arrangement of one things or filling of the one things. There are 4 ways. I mean, in general, you will say n ways.
Mostly like the confusion I get from the like where to choose a permutation, where to get the combination kind of thing. So
no. See, okay, we will cover. Let's finish the concept of permutation, and we will discuss the concept combination, and we will differentiate between this. Okay, just
sir, can you move to the sheet number 13, sir?
This one?
Yes. Here sequence, sir, I am not getting. Why n minus 2 after n minus 2, the starting n minus r plus 1, and then n
no,
minus.
It's not starting from here. It's starting from here. Okay. Concept is you have to, so see, we have to make the permutation of r objects. Okay, from a collection of n objects. Then in how many ways you can do? N for the first place, and it's without replacement. For the second place, n minus 1. For the third place, you can do n minus 2.
Yes.
For the rth place, you can do in n minus r plus 1. What is this n minus r plus 1? This is nothing but n minus r minus 1. But this is in whole bracket. If you open this bracket, it will become n minus r. Okay. So if you have this quantity, then I can multiply it and divide by this quantity. Okay.
That is
this
n minus
is nothing
r
but the n factorial. Is it clear?
Yes.
Now, okay. So for the permutation, just be careful. The permutation is nothing but the ordered arrangement.
Can you, sir, elaborate actually what is the actually ordered and unordered?
See, ordered arrangement means order is matter. Means suppose I'm saying, okay, suppose I'm saying, yeah, see, employee ID kind of things. Okay, suppose I'm saying employee ID. Okay, okay. So suppose I'm saying you have to make employee ID. Okay, from the, you can say, alphanumeric employee ID. You can, okay, and employee IDs of you can say 4 digit. Okay, so okay, in those 4 digits, 2 are alphanumeric. Okay, which is followed by the 2 numbers. Right now, let's take this. So alphanumeric I can take AB, and numbers I can take suppose 09. So this is the one employee ID, right? Okay, and another employee ID can be suppose BA 90, right? So this employee ID is same as this employee ID or different?
They are different.
So what is the meaning of they are different?
This order is means the
matter.
Order is only. Okay, understand.
Okay, order is matter. If suppose that will things comes into the combination. Suppose I have to choose just the alphabets. Suppose you have 26 alphabets. I'm saying you have to choose 4 alphabets. You can choose any 4 alphabets. Then order doesn't not matter. That means I can choose any of the A, B, C, D. I can choose. Suppose you choose initially A, B, C, D, right? First you will choose A, B, C, D, and suppose you choose like B, A, C, D. Okay, B, A, D, C. Then all the things are same. Okay, because yeah, it's on order means you have to just choose whatever it is, don't matter. It's clear?
Sir,
Okay.
Suppose in question, hello.
Yes, please.
Sir, suppose in question it is given that there are 20 laptops. Out of that, we are selecting 10 laptops, and we are giving that 10 laptops to our 10 employees. So, sir, first of all, sir, here when we are selecting 10 laptops, order is matter.
Order.
If all the laptops are the same.
This is from the I think EMQ, right?
Yes.
See,
sir.
you have 20 laptops.
Yes, sir.
Right? And there, if I'm not wrong, permutation is there, right? Order matter in that question, in the answer.
Yes,
sir,
sir,
why
order.
order?
Actually,
why
sir,
order
I will tell you. What is the question?
Actually, distinct object actually should be.
All the laptops are different.
Listen to me. You have 20 different laptops. Okay. You choose 10 laptops, right?
Yes, sir.
You choose 10 laptops. So suppose what will be the total number of it, whatever it is. Let's take you have value of how many ways you can choose. It will be 20 factorial, 10 factorial, 10 factorial, 20, whatever. Let's say m ways. Okay, let's say for simplicity, you have m ways, right? I mean, selection of 10 laptops out of 20 laptops you can do in m ways, right?
Yes, sir.
Okay. See, you choose the 10 laptops out of the 20 laptops, right? Then you have to give these 10 laptops to the different employees. Question is not till this point. Question is after this point also. Okay, you have 10 laptops.
While distributing laptops also, sir, orders doesn't matter, no?
No. There are, if there are mentioning like different things, these things should be clear too. See.
Sir, if we can open the question, then sir,
okay. Where it was in practice or
graded, sir?
In graded it was, right?
Yes, sir.
Yes, sir.
Okay. Let me open the. Have gone through the solution PDF?
Yes, sir, I gone for it. Still, they are
okay,
also
okay.
added.
Okay, well, I will explain. No worry about that. Which question it was, I think. Yeah, this one, right? Yeah, see, this is the mentioning like, see, distribution of laptops will occur simultaneously without replacement. It's clear, okay?
Yes.
See, in the question, it's also written that you have 10 different laptops, okay? Not 10, suppose, see, that's why, see, it's right here. Order of distribution of laptops do matter as, suppose you have HP laptop to given the first employee, okay, and Dell laptops to the second employee is different from the giving Dell laptops to the first and HP to the second. Right? See, suppose your laptops like can do HP, Lenovo, Dell, whatever there is, Asus, or let's take 4, okay, and you are suppose 4 employees, right? Okay, suppose employee 1 take the HP laptops, employee 2 take the Lenovo, and employee 3 take the Dell one, and employee 4 get the Asus. Okay, yes. And again employee 2 get the Lenovo, employee 1 get the, okay, let's take Dell, employee 3 get the whatever you can say, Asus, and employee 4 get the HP. This distribution of laptops is same as this one.
No.
That's why order matters.
Sir,
that's why I say just try to write the things.
Sir, okay. Sir, I read that it is written that 10 different laptops.
Yes,
but suppose
if it's not different, yeah, then order not better, because you have to distribute the laptops. Then suppose all the laptops are from HP, then all the same. Okay.
And in distribution also, order doesn't matter when we are distributing.
Yes. So that's why try to understand, try to think what is the objective of the question, right? If all the are same laptop, HP, then this, see, distribution of HP laptops, this 4 employee is same as the distribution of this HP laptop to this 4 employee, right?
Yes.
Then order doesn't matter in that case. Clear now?
Okay.
Okay.
Sir,
where we watch? Yes, please.
Sir, if we were to put the different laptops in identical bags. So instead of employees, we have to put different laptops in identical bags. So
that's why I'm saying be focus on the question. If your question is like in how many ways you can fill your laptops,
different laptops in identical bags.
Then okay, you have the identical bag. Okay.
Yeah, the same bag, same type of bag. Yeah.
Okay, same type of bag. It doesn't not matter you have same type of bag here, because you have to suppose. See, that's why I'm saying it depends on the question. Question means, suppose I'm saying you have 6 laptops, okay, and you have six bags, okay, 6 bags, 6 same types of bags, okay. Then how many ways I can fill the laptops in a bag? So whether it's same or not, it not matter, because I can fill the first bag in how many ways?
6 ways, right?
I can fill the second bag. I can fill the third bag. Okay. It is question like the question like after filling the bag, okay, after filling the laptop in the bags, then I have to choose that any 2 bag. Then order not matter.
Sir, in this also order do matter, na? Like one bag have HP laptop.
Okay, that is the thing. If you fill the laptop in the bag, then see what I say. What is the question? I said in how many way I can fill the bag. Okay. I mean I can fill the laptop in the bag.
Okay.
Okay. So I have places, right? Okay. I can fill the first one in 6 way. I can fill the second way in the 5 way. I can fill the third way in the 4 way. I can fill the 3 way, 2 way, 1 way. That's why I said it depends on the objective of the question. You should be clear. See, in this question, there was mentioned that 10 different laptops. That is the twist in the question.
If all the laptops would have been identical, then how do have been distributed among five employees?
Identical means what? They are identical, but they are still distinct, right?
Yes, of the same company, sir, such as Lenovo or HP. I mean to say.
See, identical means what?
Same brand, same model, exactly same.
Yes, sir. Yes, sir.
Okay, okay. Then you are saying these 10 identical laptops. What was your question?
Yeah, my question was if the laptops would be identical, then how would have been distributed among employees? In the same question, sir, that was being discussed.
No, I'm not getting a point.
10 laptops, 10 identical laptops in 10 employees.
Among five employees.
Among 5 employees. Okay.
Yes.
Okay. 10 laptop is not distinct.
Okay, identical laptops. So, sir, in this situation, order will matter or not?
You are saying distribution of these SP laptops to the 5 employees, right?
Yes, sir. Yes, sir.
Okay. So suppose I'm saying employee 1 get is getting the HP laptop, right?
Yes, sir.
Employee 2 is getting the HP laptop. Employee 3 is also getting the HP laptop. Employee 4 is getting the HP laptop. Employee 5 is getting the HP laptop, right?
Okay,
Again,
sir.
this is the first one. Suppose I'm saying employee 2 is getting the HP laptop. Employee 5 is getting the HP laptop. Employee 1 is getting the HP laptop. Employee 4 is getting the HP laptop. Employee 3 is getting the HP laptop. So you people will tell me, this is same as this one or not?
Yes, sir. Same. Both are
So
same.
order will matter or not?
No.
No.
That is the thing. If these laptops are different, then order will matter.
So
Okay,
then
sir.
we use combination in this. 10 C5.
See, if order not matter, you have to do just selection, then combination will be used. That's why I said, let me finish the first all the concept, and
sir.
we will
Okay,
first
okay,
finish
okay.
Yes,
the
sir. Go
Yes,
ahead,
sir.
sir.
Okay, sir. Please
Okay.
go ahead.
Now
Okay,
it's clear or not? First tell me.
clear,
It
sir.
should
Clear,
be-
sir.
Okay. If suppose instead of this HP, you have Dell and you have Lenovo, you have Asus, and one more company, whatever you can say.
Apple.
Any
Yes, sir. Yes, sir.
any
Apple.
company. Okay.
Apple.
Let's take
Yes, sir.
any Apple. Okay. Then see. One second.
Can we say that if order matters, then it is permutation, and if order does not matter, it is combination?
Yes,
You should say, right? You should say.
Just confirming that.
Yeah,
because
this is the things. If order matter, then if order matter and you are arranging the things, then permutation will be used. If order doesn't not matter and you are selecting the things, then combination will be used. That's it. Okay. So just tell me, this arrangement, this order is different from this one or not?
Yes.
Yes,
so
sir.
order will matter or not?
Yes.
Order will definitely matter.
That's it. So you should focus on the statement of the quiz, right? So it's clear to everyone or not?
Yes, sir. Clear.
Satisfies?
Yes, sir.
Okay. Let me create a new general. It's about to fill. Where we was, I think we are
actually without replacement.
Without replacement of permutation, right?
Yeah.
Okay. Thank you. Okay, see, we were at the formula of NPR. Okay, and NPR is what? N factorial divided by N minus R factorial. See, and from how you will get this? By the permutations of the R objects. Okay, that means you can get the formula of this one by the, that means permutation of R objects means, and for the first place you can take any N objects, right? At the second place you can take any N minus 1 objects, right? At the third place you can take any N minus 2 objects. Similarly, for the Rth place I can take this one, right? Is it okay or not?
Yes.
Okay, so this one is same as this formula. Okay, I explained in the previous slides. So is it clear to everyone or not?
Yes, sir. Clear.
Okay. Now you know the NP0 things. Okay, what is the meaning of this one? That means there is only one order arrangement of the 0 objects, right? What is the meaning of NP1? Anyone?
Permutation of an object out of an object.
Yes. And for that thing we have N ways, right? What is the meaning of NPN? NPN will be N factorial.
Factorial answer.
N factorial. What is this? Anyone wants to say? In a layman term.
Yes, sir.
And out of an
arrangement
Arranging
of
all the
different
inputs.
objects at N place.
Yes. Or you can say, yes, it's right. That means I can also say this is the multiplication rule of counting. Can I say or not?
Yes, sir.
Yes.
For
Yes,
the N
sir.
factorial, I can say it is multiplication rule of counting or not?
Yes, yes.
I can say, right?
Yes, sir.
Okay. Now, this was the about without replacement. Okay. Suppose I want to do the permutations of the R objects from a collection of n distinct objects where repetition is allowed. Then what will be the number of ways where repetition is allowed? That means for the first place, in how many way I can do?
N way.
N way.
Right. See, repetition is allowed means the things which I have used at the first place, I can also use the same things for the second place.
Yes.
That means for the second place, in how many ways you have?
N ways. N ways.
For the third place?
N.
Similarly, for the rth place?
N.
Then what will be the total number of ways?
N into R.
N power R.
N power R.
Is it clear? Because see, n into n means what? N is square. N into n means what? N cube. That means multiplication of R times will be, this is what? Multiplication of the R times. It will be the n raised power R. Is it clear?
Yes, sir.
Okay. Is it clear to everyone or not?
Yes, sir.
Okay.
Actually, yes, sir, I have one doubt. Actually, when we are deciding whether it is repetition is allowed or not in the question, sometimes it is hidden.
It will be question.
No, sometimes it is not telling, but so how to extract the meaning out of this? What?
Then you have to think. You have to think. See, you have to think. Just just take the example of that patriotic movie example. Okay. Okay. So, okay. Suppose I had okay. Suppose I have 8 students, right? And each students have 3 ways, right? See, try to understand. He can see, he has 3 ways. That means he can respond like he liked the movie,
yes,
he
sir,
did
no.
not like the movie, or did not
Respond.
did not
No
respond. No? That means he has 3 ways, right? For the first student, how many way you have? 3 ways.
Three ways.
Similarly, for the second, for the third, for the fourth student, for the fifth student, for the sixth student, for the seventh student, for the eighth student, right? Then how many ways you have?
3 to the power 8.
3 power 8.
Okay, I think that should be the correct one. It was in week 5, right? Not wrong. What is the value of 3 raised power 8?
5 into.
Sorry?
5 into.
1 second.
729. Achha.
No, 3 raised power 8.
6561.
Okay. So, see, the question is here, what is this? What is this? This is same as the 3 into 3 into 3 into 3 into 3 into 3, 6 times, 7 times, and 8. That is the 3 raised power. That is. Okay. Here things are not, if you see, for each one, you have like kind of with repetition. It's not a meaning of exact with repetition. If you see, if you know, compare like n into n into n into n into n r times, that is the n that I'm trying to say. So, for first of all, it will be mentioned like without replacement, you are choosing the things, with repetition. Suppose you are making the password of 4 digits with repetition. Repetition of digits is allowed, repetition of digits is not allowed. So it will be there. No worry about that. Okay.
Okay.
If it's simple, then don't think.
Sir, in such type of problems, I also get confused in identifying which one is N and which one is R all the time, sir.
In which question?
When repetition is allowed, sir. Such as if five.
Yes, okay. Tell
if
me.
5 ice cream is distributed between 3 students,
Hmm.
so here which one will be which one is to consider N and which one is to consider R?
Okay. first up, tell me what is the meaning of NPR? So R should be less or equal to N or not?
Yes, sir. R should be less.
So you are doing the things.
No, sir. Not in this type of question. When repetition is allowed, N to the power R cases
Okay,
when
don't worry about that. Don't apply the direct formula. Okay. See, I did the things for the. He said in some question repetition or not mentioned. I said here repetition for the each students have 3 options. I mean 3 is repeated. Okay, that means that's what I want to say, because see. Question is not like if student 1 is respond, then he for the second student he has only 2 options. Suppose first student did not respond, then for the second student he has only 2 options, whether he liked the movie or did not like the movie. It was not like that. It was like that in everyone has 3 options. Okay, that means everyone has with repetition kind of things. Okay, that means these options are repeating. That's why I used there. Don't worry about that and rest for the R kind of things. See, and rest for the R is what? This is nothing but the arrangement of the R. I mean, you can say permutation. Yes. No. See,
when repetition is allowed, sir.
Yes, when repetition is allowed. That means, see, you have R places. Suppose let's take for the 4 places. Okay. Let's take example of 4 places. So for the first places, in how many ways you can do?
N ways.
N ways.
For second place?
N ways.
For third place?
N ways.
For the fourth place?
N ways, sir.
So what is this? You can interpret 4 as a R.
Yes, sir.
Okay. And N is, you have N, whatever, how many total? So what is the total number of ways? N raised power?
4.
So instead of 4, suppose you have Rth place, then what will be this? N into N up to R times. That means N raised power?
N raised to power R. Yes.
Okay. N is your total collection, you can say, and R is in how, I mean, what permutation you want to do. I mean permutation of how many objects you want to do.
Yes, sir.
Is it clear or not?
Yes, sir. Yes, sir. Clear, sir.
Okay.
Okay, sir.
So till this point, anyone has any doubt?
Yes, sir. Graded assignment question number 3. Graded assignment 6, part 1, question number 3.
Okay, can we discuss at the end? And,
one more topic left, actually, circular.
No, I just covered the permutation, and that's why I say, see, let's finish all the topics of the week sale. Then we will discuss the questions, because in some questions combination is used, in some questions circular permutation is used. So let's finish all the topics and we will discuss the question. Okay.
Okay, sir.
Then
okay.
we will be able to differentiate between the what is the permutation and combination, right?
Yeah, sure.
Now, so okay. So now let's come through the points. Like suppose I'm saying. The number of permutations, okay, you people will tell me what will be the number of permutation, or you can say number of ways or number of possible choices or whatever for n objects when p objects of them are same, or you can say p objects of them are one kind and rest are the distinct. Then how many ways you can do? You have n objects. Listen to me. You have n objects, and p of them are the same kind. Okay, one kind, and rest of the objects of these n items are distinct. Then in how many ways you can do?
Sir, factorial n by factorial p.
N factorial divided by
factorial p.
Because suppose you have an example of, like suppose I have an example of laptop. Okay, then suppose I want to rearrange the letters of laptops, then in how many ways can I do?
Factorial 6, sir.
Factorial 6 by factorial 2.
Factorial 2.
Why factorial 2?
P is
because p is repeated
P is the letter P is the 2 times. Also I can do 1 factorial for laptop 1, 1 factorial for laptop 1 factorial for L, 1 factorial for A, 1 factorial for T, 1 factorial for, but it's same as the 6 factorial divided by. It's clear or not?
Yes, sir. Clear, sir.
Yes, sir.
Yes, sir.
Now, suppose, see, this is for the, suppose you have n objects, right? And P1 is of the same kind, P2 objects are of the same kind. This is the one kind of things. This is the second kind of thing. This is the third kind of things. Okay, whatever you can say. Then, in how many ways you can do?
And factorial and divided by
Factorial
P1, P2,
factorial P2, P3 factorial.
P3. Suppose it's up to Pk. That means it will be up to Pk factorial. So let's take the example of that laptop. Okay. Then in how many total letters you have? 5. That means 5 factorial. Here your n is what? 5? No, 6. Right?
Yes, sir.
Right? Now let's take one kind means see. P is one kind, that means 2 factorial. I can write 1 factorial for L, 1 factorial for A, 1 factorial for T, 1 factorial for O. Is it clear or not?
Yes, sir.
Okay. Suppose instead of laptops, any letter like there too much this and I can say any words.
Statistics, sir.
Okay, statistics. Right. Then what is your n is and you have here 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then 10 factorial. Suppose I want to, in how many ways I can rearrange? Sorry?
By 3 factorial. 10 factorial by 3 factorial, because there are 3 T's.
Yeah, 3 T's, 3 factorial, right?
2 factorial, because no, 3 factorial again, because there is
3s. Okay, right?
And 2 factorial, because there is 2i.
2i. 1 factorial for A, 1 factorial for
C.
Is it clear to everyone? Hello?
Yes,
sir.
Yes, sir.
This thing is clear to everyone, right? Now, okay, let's move for the circular permutation, right? See, there is two things, clockwise and anti-clockwise. Okay, now, suppose what will be the number of ways to arranging the n distinct objects, okay, when your clockwise, okay, and anti-clockwise are different. In how many ways you can do to arrange the n distinct objects to a circular path in a circle, or you can say when clockwise and anti-clockwise are different, then in how many ways you can do?
n minus 1 factorial.
N minus 1 factorial.
N minus 1. Okay, so any people can tell me how this n minus 1 factorial came?
Yes, sir. Because in the circular arrangement, we fix one person for reference. And thereafter, we arrange n minus 1 factor in a linear fashion, n minus 1 factorial base.
Okay, anyone else?
Yes, sir, because in a circular arrangement, there is no specific start or end. It's not identifiable, a specific start or end point.
Okay,
so,
anyone else? Yeah, right, Akash. Anyone else?
Then there are different objects, so clockwise and anti-clockwise arrangement are also different. So we are taking in linear fashion.
Okay, let's take an example of 4. Let's take 4 objects. Okay, suppose I have A, right? B, C, and D, right? Now, then see, just tell me in general, arranging the 4 people at the 4 places, in how many you can do?
Factorial 4 ways.
4 factorial, right? This is clear or not? right? I can do the same things as suppose I can do the A, B, C, T, right?
Yes, sir.
Can I do or not?
Yes, sir.
Similarly, I can do A, B, C, D.
Yes, sir.
Okay. Then what is this? You can repeat it. You are repeating the four items. That means what? I can do the things or not? I can do divide by 4 or not?
Yes, sir.
Okay. That means what? 4 into 3 factorial divided by 4. That is nothing but the 3 factorial. That means circular arrangement of the 4 people at a circular path when clockwise and anti-clockwise are different, then which can be done in the 3 factorial way. It's clear to everyone or not?
Clear, sir.
Actually, anti-clockwise and clockwise are different. What actually meaning here
Meaning
is
of
this
that. Okay. I will tell you. See, suppose you have A, B, C, D, right? Okay. And I'm saying let me take okay, A, C, I can take D, I can take B, right? Okay. Also, I can do A, D, let's take B, let's take C, right? I can also arrange the same things A, D, C, B, right? I can also do the things A, B, D, C. Here I can also do A, C, D, D, right? अपने हाथ से ना कूलिंग Hurry, please mute yourself. Yeah. So if you see clockwise and anti-clockwise are different ways. If you go clockwise, that means you have what here? A, B, C, and D. That means you have A, B, C, and D, right? Right or not?
Yes, sir.
Yes, sir.
Yes, sir.
So if you go anti-clockwise, that means you have A, D, C, and B. That means you have arrangement of A, D, C, and B. Okay.
Yes, sir.
So is this arrangement and this arrangement same or not?
No, sir.
No,
No,
that
it is
means
different.
clockwise and anti-clockwise are different,
Hmm.
right? Similarly, if you go for this one, then your anti-clockwise will be what? A, B, D, C, right? What will be the clockwise? A,
A, C, D, B.
D, B. So this one is different from this one.
Yes, sir.
Okay. Similarly for the this one, and this one, right?
So, sir, for different objects, clock and anti-clock will always be different, and for the same objects, we can say the clock and anti-clockwise are same.
Sometimes you can't say in general. Sometimes for different, it can be same. I will tell you. First, tell me this one is clear or not? Meaning
Clear,
of
sir.
clock, meaning
Yes,
of
sir.
the clockwise and anti-clockwise.
Yes,
But
sir.
order is,
Clear.
sir, order is the different, and you are putting condition that both are same. Like
Both are
this is
same.
no, order is different. A, B, C, D is different from A, D, C, B. And here you are telling you are putting condition that clockwise and anti-clockwise combination means order is same.
When I said it's same, I said when you clockwise and anti-clockwise are different, right? So this one is different from this one.
Order is different.
Right? See, this arrangement, arrangement of ABCD is different from arrangement of ADCB or not?
That is clear.
That means what? Your clockwise and anti-clockwise are different. Right? Right
Yes.
or not? Right?
Yes,
that means if you go clockwise and if you do arrangement anti-clockwise, these two are different. If arrangement of n objects in a circular path when a clockwise and anti-clockwise are different, then you have in how many ways? N minus 1 factorial ways, right? That means here you have 4 objects. That means 4 minus 1 factorial. That means 3 factorial. That means 3 into 2 into 1. That is 6 way. So those 6 ways, this one. Right way?
Okay.
This one way. This is 2 way. This is 3rd way. 4th way. This is the 5th way. This is the 6th way.
I understand.
Okay.
Next.
Now, is it clear to everyone or not?
Sir, in the previous slide, why you divide by 4? I don't know.
No. See, that's okay. That's why I said, see, in this one, I said, like, see, your A, B, C, D. That is the concept to telling you funda behind the n minus 1.
Yes, sir.
Okay. So you have ABCD, right?
Yes, sir.
I can do ABCD.
Yes, sir.
Right? So you can do the things in a 4 way or not?
Yes, sir. You can.
Okay. So see, in general, arrangement of 4 people you can do in 4 factorial ways.
Yes, sir.
You can do these things in 4 way.
Yes.
Then what you will get? 3 factorial.
Okay, sir.
Okay. That means arrangement of 4 people in circular path is 3 factorial. Right?
Okay, sir.
No.
So
okay.
We can also say, so in the previous slide, please go to the previous slide, sir.
This one, right?
No, sir.
This one.
Yes, sir. We can also say that, sir, each circular arrangement of 4 objects gives rise to 4 linear arrangements, which are same in circular arrangement. A, B, C, D, sir. Here, if we place A to the second place, it will be the same circular
then again
arrangement.
you will get ABCD.
Yes, sir. That's why we are dividing by 4 because all are same arrangement.
Yes, this is for the n, and this you can do n factorial, right?
Yes, sir.
And you see,
yes, sir. We will divide it by n.
For the n objects, you can do in the n factorial ways, and
yes,
you can do in the n ways, right? That means you will get the n factorial.
N minus 1
this
factorial.
is the number of ways for arranging the n distinct object to a circular path when your clockwise and anti-clockwise are different. Right? Now, let's move for the clockwise and anti-clockwise same. Okay? Clockwise and anti-clockwise are same. Clockwise and anti-clockwise same is, suppose you have A, B, okay, C and D, right? Then again I say A, let's say A here, B, C, D, okay? So if you go clockwise, then what is the arrangement? ABCD. If you go anti-clockwise, no, I think this one is different. It should be A, B, C, right? If you go anti-clockwise, again you are getting the ABCD, right?
Yes, sir.
So here clockwise and anti-clockwise are same. Nitish, from your side, there is some background noise. Okay, so you got the meaning clockwise and anti-clockwise same or not? Hello.
Yes, sir.
Okay, see, if clockwise and anti-clockwise same, then what is, I mean, how many ways you have?
Same.
Sorry?
N minus 1 factorial by 2.
Yes, sir. These 2 arrangements will be considered as one arrangement.
Yes. So similarly, for if you go for the previous one, these 2 arrangement is considered, can be considered as the one way, one arrangement.
Yes.
Because if you go clockwise, see, let me erase the. Yeah, see, if you go here, clockwise, then what arrangement you will get? A, B, C, D, right? Right or not?
Yes, sir.
Okay. For
Yes, sir.
this clockwise arrangement, you will get A, C, D, B.
DB. Yes.
For this, A, D, B, C. For this, if you go, see, let me go anti-clockwise. So anti-clockwise, if you will go, what you will get? A, B, C, D. Right? For this, A, C, D, B, anti-clock means this, 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 this. And for this, A, D, B, C. Right? So this arrangement is same as this arrangement. Right? What is the meaning? When your clockwise and anti-clockwise are same, then see, initially when your clockwise and anti-clockwise was different, then you how many ways you had? 3 factorial, right?
N minus 1.
And see, n minus 1 for n objects. I took the 3 factorial for the 4 objects. Then you had 3 factorial, right?
Yes, sir.
That means 6 ways. Now in how many ways you have?
3 ways, sir.
That means 6 divided by 2.
3 factorial divided by 2.
That is the concept. So similarly, you can do for the n objects. Yes.
Here, sir, we are supposing anti-clockwise and clockwise arrangement are same. A, B,
Yes,
C, D,
yes.
and but sir, in natural cases such as the case of beads, how can we, sir, do all these things?
Suppose this one, okay? Black, okay? Okay, this one is suppose arrangement.
Yes.
Okay.
Yes.
Then if you go clockwise, then what will you get?
Black, blue.
Black.
Black, blue, black.
Black, blue, black, blue, black, blue, right?
Yes, sir.
Yes, sir.
If you go anti-clockwise with
black, blue,
black, blue,
yes, sir.
black, right?
Yes, sir.
Now it's clear.
Yes, sir.
Yes,
Clock
sir.
and anti-clockwise arrangement are same.
Because
Same.
beads are somehow are identical in size and kind of thing. You can see you can visualize like if you have necklace with beads, just put it in front of the mirror.
Yes, sir.
Then beads you can get in both same way, right? It is clear now or not?
Clear, sir. Clear.
Clear to everyone?
You can go ahead.
So now it's clear. Clockwise, anti-clockwise concept to everyone.
Starting point should be same. This is one.
Same means see what? This should be like, see, this is something as if you A, arrangement is matter B, C, D, right? Then I have A, B, C, D. That's it. This one is the same as this one, right?
So we have to choose a starting point and you have
Yes,
to check
yes.
the yes.
Yes, the starting point. We have to
Okay. So now till this point, anyone else have any doubt?
No, sir.
Okay, let's move. So now let's see. What you people will tell me. What was the meaning of permutation?
Arrangement
Ordered arrangement of
Ordered
R
Yes,
objects out
yes.
of N.
This is the very important thing. Ordered arrangement of the
N
R
objects
object.
out of R object
Yes.
out of
R
N.
objects out of N
So
objects.
in permutation, order is matter, and you have to do the arrangement also, right? Now, what is the combination? Combination is what? You have to find some combination, some group, right? Some you can say. So in combination, selection is there, okay? And order is not important in combination. So this is the basic funda of the permutation and the combination. Right?
Right, sir.
Is
Yes,
it
sir.
clear or not?
Clear,
Permutation is what? You have to do the order arrangement of the things, and combination is what? You have to do just a selection of the things. Order is not important in the combination. combination. Is it clear to everyone or not?
Yes.
Just let me take example. Suppose you have 3 people. Okay. I have to make a group of 2 people where order is matter. Then what it will be?
A, B,
AB,
B, A.
C, A, B, A, C.
AC.
Okay. Let's take order is not important. Then AB, BC, AC. These 3 are possible.
Yes, sir.
Right? Because AB same as BA, BC same as CB, and AC same as CA. Right?
Right, sir.
Then what is this? Arrangement possible arrangement of 2 people out of 3 people. In how many ways you can do?
6 ways.
No, 6 way. 6 way.
Yes, sir. Arrangement, sir.
Yeah, for arrangement it should be 6, sir.
Yeah,
Because
for it will be 6. Okay. Now, see, because one factorial will be cancelled out, like it will be 6, right? That means your AB is different from BA.
BA.
Your BC is different from
CB.
And your AC is different from
CA.
So this is the something permutation is AB. This order is different from this order. If this order is different from this order and this order is different from this order, then what is this? This is nothing but the 3P2.
Yes, sir.
Right?
Yes,
in
sir.
general, you can do like 3 people. You have to arrange at the 2 places. At the first places, you can do in the 3 ways, and for the second places, you have to do in the 2 ways. That is the 6. So you got the chain point between these 2 and these 2. Right?
Right, sir.
It's right to everyone, right? Now, here order is met. Suppose I have to make the group of 2 people, or I have to do the selection of 2 people between, from these 3 people, then in how many way I can do the selection?
3 way.
See,
3C2.
AB, BC,
3C2.
AC, yeah, one second, BA, CB, C. See, initially, we should have like this 6 pair. Okay, we will get this 6 pair. But I said I have to just select the 2 people from these 3 people. Then selection of AB is same as the selection of BA, because in these 2 selection, I have just selected the 2 people. I have selected the AB and BA, right?
Right, sir.
Yes, sir.
In these 2 selection, I have selected B and C. In these 2 selection, I have selected A and C, because we are not considering about the order, right?
Yes, sir.
So this all things are same. Then how many ways you have? 3 way. What is this 3 way? That is the 3C2 way. That means you have to choose, you have to select 2 people from 3 people. You can choose in 3C2 way, that is 3 factorial, 2 factorial, and 1 factorial. Because combination, choosing the selection of R objects from N objects, you can do in NCR ways, which is nothing but N factorial divided by R factorial into N minus R factorial. If you solve this, you will get 3 into 2 factorial. 2 factorial will get cancelled out, and you will get the 3. This is this 3 same as this 3. This one is clear or not?
Yes, clear, sir. Can go ahead.
Okay.
Yes, sir.
Is it clear? Now, in some question, you will get like first selection and then arrangement. Right? Suppose in the previous and 3% example, suppose I want to say I have to select the 2 people from these 3 people, A, B, and C, and then I have to arrange. Then first I have to select these 2 people from the 3 people. In how many ways I can do? 3C2 way. right?
Yes, sir.
Right now. Then these two people, in how many ways I can arrange?
Factorial
2
2.
factorial.
Factorial.
So can I say into multiplied by 2 factorial?
Yes.
Yes, sir.
Question is what? Try to understand. First, you have to select 2 people from the 3 people. After that, you have to arrange these 2 people, which you can do in 2 factorial ways. So this is the same as 3p2 or not?
Yes, sir. Same.
Are you getting my point or not?
Yes, sir. Yes.
Getting, sir.
Yes, sir.
Getting? So
yes.
you know the general formula, NCR into R factorial is equal to
NPR.
NP. So this formula is, you can say like important kind of things.
Sir, like in this type of question, when question is asking permutation is used or combination used, so then we have to choose permutation, because ultimately we are doing permutation.
Yeah, see here what you are doing. You are doing the permutation. First you selected the people, right? After that you are arranging people. Suppose you select the people AB, right?
Yes,
Then in
sir.
how many ways you can arrange these 2 people?
Factorial 2.
2 factorial.
Okay.
Okay. See, just try to understand if there is order matter, okay, and you are arranging the things, then permutation is permutation will be used. Here you are arranging the things and order matter is AB is different from the BA. So that's why permutation will be used. Combination means selection is there, right?
Yes, sir.
And order not matter.
Yes.
Suppose in this one I selected AB, you can select C. You can select A, you can select B, or you can select B, or you can select A. But in final, you have selected only 2. I mean A and B. So here order is not matter. You have just selected.
Yes,
is it
sir.
clear to everyone or not?
Yes, sir.
Clear, sir.
Clear?
Yes, sir.
Yes, sir.
Now, you know NCN. By formula, you will get what?
N to the power R.
NCN 1, sir. 1, sir. 1.
Why N to the power R?
Oh, sir,
See,
my bad.
you
And,
have
you
have
I
3
got
people.
it, sir. I got it. My bad.
Okay, you have 3 people. You have to choose these 3 people in how many ways you can?
One way, sir.
One way.
That's it.
My bad,
Okay.
sir.
Okay. And suppose NC0.
1.
1.
Sir, it's 1.
That's it. And you see, you can do by the formula also. N factorial divided by R factorial. R is N, and N minus R factorial will be 0. Similarly for this one. Right?
Right, sir.
All the things will be cancelled out. And there is one more important formula which you have to you can remember the things. You know this formula NCR equal to N minus 1 CR minus 1 plus N minus 1 CR. Right? And there is some concept I think I has clearly explained. And see, what is the condition of R?
1, 2.
Right? Okay. Now, let's move further. Yeah, you can remember this. Okay, so let's move for suppose you know.
Sir, R is equal to and greater than 1 and smaller than n, right? This one?
No, this is for this condition one.
Okay. Got it.
This particular condition, but in general, your R should be less or equal to 1. No upper limit, lower limit for this. Because suppose you have one object, then you can do 1 is 0, right?
Yeah.
Here R is from 1 because you have n minus 1. Suppose your R goes less than 1. Suppose you put 0, then what is the meaning of choosing minus 1 object? No meaning is there, right?
Yes, right.
Okay. No.
In that case, value will be 1. 1 C 0.
1. So yeah, you know cards things. I mean, there are 52 cards, all things. You are familiar with that, right?
Yes, sir.
Yes, sir.
Okay. Suppose I want to say, I want to choose 4 cards. I have to select four cards from those 52 cards, then in how many ways I can do?
52C4, sir.
That's it. Yeah, cause syllabus of quiz 2 will be from week 1 to week 8, but major portion will be from week 5 to week 8. Okay. Okay, you can do it. This one is 52C4. Okay, right. Suppose I'm saying all cards, all four cards are from the same suit. Same suit means there are four suits, right?
Yes, sir.
Right, sir.
Yes, sir.
Which one?
A spade, club.
Yeah.
Spade, club,
spade,
diamond,
diamond,
heart.
Club,
heart, diamond.
Diamond.
Right? Okay. And each one has 13 cards, right?
Yes, sir.
Okay. That numbers from 2 to 9, and one ace, one king, queen, jack.
Three chess cards, yes.
Yeah. Suppose I'm saying you have to choose these four cards, and all four cards are from the same suit. Then how many ways you can do?
13C4.
13C4, 13C4, 13C4.
First we
into 4.
4C1 into 4C1, sir.
Yeah. See, there are interpretation of this, or you can do. See, you have to choose the four cards from the same suit. That is, I can choose these four cards from the spade. Okay.
Or from club.
Or I can choose from the club. Or I can choose from the heart, and I can choose from the diamond, right?
Yes, sir.
It is clear or not? So what is this? 4 into 13C4, right?
Yes.
Or this is the one approach. Another approach is you have four suit, right? And you have to choose the four cards from the same suit. So first you have to choose the any one suit. I mean, you have to choose the one suit. That is, out of four suit, you can choose one suit in how many ways? 4C, one ways. Now, let try to understand me. See, you can choose the one suit from the four suit in how many ways? 4C1.
4C1. And simultaneously,
now you have selected, you have choose the one suit already, and those four cards should be from this suit and from same suit. That means and 13C4. You have selected the suit and selected the four cards from the suit. Or you can approach it like this way. So both way is clear or not?
Yes, sir. Clear.
Yes, sir.
Okay. Suppose instead of doing say, suppose I am saying, yeah, your all four cards are from the same color. First, tell me how many colors are there in the cards?
Two colors.
Red and black.
Red and black. Yeah.
Red and black. Okay. I'm saying these four cards should be from same color. So first tell me.
So 26.
2 into 26.
26, yeah.
Okay. So how many cards are there for red?
26, sir.
26 and 26 for
black, sir.
Black, right? Now, I'm saying these four cards should be from the same color. Means either it can be from red color or from black color. So I can approach like 26C.
26C2.
4, not 2. Why? I'm selecting four cards.
Okay, four cards, yeah.
Okay. Or it can be 26C4, 26C4. This is the one way. Another way is, let me choose one color from the two colors and cards from the.
Or 2 into 26C4.
And this is the same as 2 into 26C. So these two things is clear or not?
Yes, sir, clear.
Yes.
Everyone is getting the point?
Yes, sir.
Yes, sir.
Now, you people will tell me now. Suppose you on a circle, okay, 2 points is there, right? Then how many lines
one line
you can draw to connecting these 2 points?
One line.
One line, sir.
One line, sir.
That means what? Suppose this is the A, this is the B. Then I can say can I say 2C2?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Anyone can tell me why I'm saying like this?
Selecting 2 points out of 2.
Yes, because you have 2 points. See, for making the lines to connecting these 2 points, you should these 2 points, right? You must have these 2 points, and you are see that who said that selecting 2 points?
Me, sir.
Sir, yeah, you are right. You are selecting 2 points out of the 2 points. That is the one way. Okay.
Yes, sir.
Suppose you have 3 points. Then how many ways you have?
3C2.
3C2.
Because we have to choose 2
A,
points out of
B,
3.
C. Because see, for 3 points, for making a lines, you need 2 points. Try to understand the combination. From the 3 points, for making a line, I need 2 points. That means
sir.
I can choose any 2 points from the 3 points.
Yes, sir.
Right or not?
Right.
Yes.
Sir.
What will be this? This will be, I think, 3 factorial, 2 factorial, 1 factorial. It will be 3 into 2 factorial. 2 factorial will be cancelled out 3 ways. Right? Now, 1 way. Right?
Right, sir.
2 way and 3 way. Is it clear or not?
Yes, sir.
Clear, sir.
So in general, can I say if you have n points, then number of line segments that can be drawn to by connecting these points in NC2 ways, right? It's clear. It's clear to everyone.
Yes. Sir, actually, I got confused when there is a 2 words. I mean, interchangingly used, selecting versus some arranging. No, not arranging. Selecting versus
choose.
I'm not getting that word, sir. Actually, if you in week 6 graded assignment, there is a word.
Selecting and choosing. There are 2 words used frequently interchangeably.
Yeah.
Choosing is the same as selecting.
No, that's
Why confused?
Which question?
Suppose you have 3 people, right? I want to choose 2 people. Then in how many ways I can choose?
Yeah.
In how many ways I can select?
3C2 as well.
Instead of choosing or selecting, I want to arrange the people at 2 places, or you can say, then permutation will be used.
3P2.
Okay. See, you must be clear. First, only one thing: order is matter or not. If order is matter, then permutation. And order is not matter, and you are doing only selection, then it's a combination. See, order, when order will be matter. Suppose you have 2 places, right? And you are arranging the people. I'm getting my point, because you have 2 places, right? You see, tell me, you have 3 people. At the first places, in how many people you can do? I mean, you can arrange?
3, sir.
3. At the second?
2.
That is 6. That is what? If you are putting the first at the first place A and at the second place B, this one is the different from if you put the B at the first place and A is the second place.
Yes, sir.
That's, see, you must be clear order is matter or not. If order matter, then permutation will be used. If order does not matter, then combination will be used. That's it. Let's take example of that. Okay, let's take example. If you remember that athletes thing, ma'am took the example.
Sir, that's why EMQ questions has given.
Yes. See, you That's why, see, that's why there are a lot of questions. Order matters. Order. See, I took the example of laptops. Okay, if you see 10 different laptops, so suppose, yeah, suppose, what is your name? San, right?
Vishwajit.
Vishwajit. Suppose Vishwajit, I gave the laptop to the Vishwajit of HP, right? Okay, I give to you HP laptop. Okay, suppose okay. Now, suppose I give the laptop to Saad, Lenovo. Okay, and again I say I give the laptop to the Vishwajit, Lenovo, and Saad, HP. So this order is different from this one or not?
Yes.
Different. That means order is matter. Again, suppose I say you are getting the HP laptop and Saad is also getting the HP laptop, and this you are getting HP laptop and you are getting. So this order is different from this one or not?
Yes. No, same.
No, sir. Same.
No difference.
So that's why you must be clear. I want to say, right?
So,
syllabus of. See,
in the most of the time, sir, combination used when matching the table will come. Matching the table, right?
Matching the table means what?
For example, just now you show us. It's a table, right? A table is consisting of a name and B table is consisting of a laptop name. So when match, we are matching the two items. In that case, combination will apply, right?
You can do like hello. Am I
yes,
audible?
sir. Yeah.
Yes, if someone is writing from syllabus for quiz 2 is not up to week 9, it will be up to week 8. Okay. Okay, say I'm saying like suppose I'm giving I gave to HP laptop to you, okay, to Saad Lenovo, right? Okay, then this order is different from this one, right?
Yes.
Okay, so here orders matter. Okay, let's take another example that if you remember, suppose you have eight athletes, right? They are participating in some 200-meter race or kinds of things. Okay, then suppose I'm saying in how many ways, how many different ways you can say I can award the athlete by the gold, silver, and bronze medal. Okay, then just tell me here order will matter or not?
Yes, matters.
Order will matter.
Why order matter?
Because after gold, silver will come after gold, and bronze will come after silver.
Okay, any other reason?
So suppose one person get gold and another order it will get silver. So these two are different things.
Sir, first position always given to gold. Gold medal given to first position holder, sir.
Yes, that we see. Suppose A get the gold medal, right? B get the silver medal, and C get the bronze medal. This is the different. If A get the silver medal, okay, B get the gold medal, and C get the bronze medal. So this order is different from this. Am I right or not?
Yes, sir.
Right, sir. So that is the funda of the things. You must be clear at whether order is better or not. Here order matter. That means you have to do permutation. That's all. That means you have 8 people and you have to kind of, you can say, you have to arrange at the 3 places. Then in how many ways you can do 8p 3. Is it clear or not?
Yes, sir. That means whenever arranging will apply, permutation will apply. I mean, at that moment.
Arranging and order and match.
Selecting.
Yes, please.
Like in the question, if prize is given or ranking is given, then order will definitely matter.
Order will definitely. Yes. Okay. Till this point is clear or not?
Clear, sir.
Okay, let me create a new journal.
The same question came, sir, in week 4 or 5. I don't.
Okay.
I mean, I don't remember. Football number, jersey number, and football players. So order doesn't matter.
I also I'm not. I don't remember that. Okay, now you got the gold, silver, and bronze, right? Now, suppose I'm saying in how many different ways you can choose the top 3 athletes or top 4 athletes to proceed with the next 3 rounds. I mean, next round. Then how many ways you can do?
Top 4, sir, 8C4.
Yeah.
Suppose I'm taking top 4 or top 3, let's say. Then in how many ways I can do?
It's 8C3.
8C3. Okay. Why not 8P3?
Because here we are choosing, not arranging, sir.
Not arranging also, see, and order is not matter. What, see, try to focus on I said top 3 athletes will go for the next round. Okay, so suppose top 3, A at the first place, B at the second place, and C at the third place, right? Again, B at the first place, A at the second place, C at the third place, B at the first place, C at the second place, A at the third place. So even places are, see, here A is first, here B is first, here B is first, C is second. But if you see, these 3 are what? Top 3 athletes?
A, B, C.
In
Order doesn't matter.
Finally, A, B, and C will go for the next round. So getting position here, order is not matter.
Order doesn't matter, yes.
Yeah, because
Order
at
does
the
not
end we
matter.
are choosing only 3.
So here,
Yes.
here we are choosing only top 3 out of 8. That is 8C. Suppose one thing. Suppose you choose the 3. You choose the 3 athletes, right? Now, after choosing the 3 athletes, you want to say like, I want to give the ranking to these 3 people. Then you can do in 3 factorial ways.
Order matters, yes, sir.
Okay. After I'm saying you choose the top 3. Suppose I choose the top 3 athletes, which who are A, B, and C. Okay. I choose A, B, and C. Right. These are the top 3. Now I want to say, I want to give like you can say, I want to give suppose I want to give jersey number 1 to A, jersey number 2 to B, jersey number 3 to C. Okay. Then jersey number 2 A, jersey number 3 to B, jersey number 1 to A. So if you after choosing these 3 people, if you want to say like you want to give some ranking kind of things, you want to give some different kind of things, that means you are arranging after selecting these 3 people.
Yes, sir.
Yes.
You are getting my point or not? I want to try to say, even you are selecting the people, if after the selection you want to arrange the things, arrange the people, then it will become permutation, because it will become 8P3, because NCR into R factorial is nothing but the NPR. But this thing is clear or not?
Clear, sir.
Yes.
Sir, I have a question, sir. Sir,
Yes.
You are saying that we have to arrange out of 3, right? So it should be 3P3, right? Instead of 8P3?
No, not 8. No. See, you are getting a visa at this jersey.
We have already chosen, sir, 3 people, right? So we out of 3, we have to give rank to 1, 2, and 3, right?
Okay.
So in that case, it wouldn't be 3P3.
1 second. What first what you do? You choose the 3 people.
Yes, sir.
Yes, sir.
And after choosing, you are arranging these 3 people.
Yes.
Then what these things?
8P3.
8P3.
Whether you are, see, if you select the people and then arranging the people, it will become automatically permutation.
Oh, okay. Got it, sir.
Got it?
Clear, sir.
So you know what is the concept difference between permutation and combination?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay, let me tell you. See, suppose you have a class of 30 students. Okay. Okay. Now, I want to choose two leaders from these 30 students. Then in how many way I can choose?
30C2.
30C2. Now, let me tell. Now, suppose I want to choose a captain and a vice captain from this 30 students. In how many way I can do?
30P2.
30P2, sir.
30P2.
Why 30P2?
Because we
have to arrange.
Captain,
But
vice
I-
captain.
But I
Order
use
matters,
the
yes.
Order doesn't matter.
Order matters.
Order matters.
One second, one by one. I said I have to choose a captain and a vice captain. But I use the word of choose. Then why not 30C2?
Because we have to arrange after choosing.
Yes.
Sir,
Right?
one quick reminder, your battery is getting out. Connect your charger, please.
Okay. Thank you.
Last time you were, your laptop got shut down and you got disconnected in between session.
Oh, thank you so much. Okay, see. So initially you had 30 students, right? I said I want to choose two leaders from the class. Okay. Then in how many ways I can do? 30C2. Because I can choose any two students out of these 30 students, right? Now it's clear or not? Hello?
It's clear.
Yes, okay, now suppose I said I have to choose a captain and a vice captain. Then in how many ways I can do?
30P2.
But I said choosing.
Choose now.
Okay. Okay, let's take. I choose two people, right? But choose what? A captain and a vice captain. So order is better.
Yes, sir. Order
Yes,
matters.
sir.
Because see, two leaders, what? It can be anyone. It can be anything, right? But I have to choose a captain and vice captain. I choose the two people from 30 people, and after that I have to give the arrangement kind of thing. And in how many ways I can give the arrangement?
Factorial.
2 factorial.
And what is this?
30P2.
30P. So if order matter, then you have to use the permutation. If order does not matter, then you have to use the combination. If it's clear or not?
Yes, sir.
Clear, sir.
Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Now, suppose you told me initially. Suppose you have given 2 points on a circle. Then how many lines segment you can draw?
One.
A 1. That was 2C2, right?
Yes, sir.
But you said in when order is not matter, whether I'm going A to B or B to A, right?
Exactly.
But if A to B, right, and B to A is different, then what?
2 lines.
We have to arrange
2 lines.
2P2.
That means
4 points, right, sir?
2P2.
No, not 4 points.
Oh, okay,
not
okay.
4 points. It's same. So be focused on the arrow.
Yes, sir.
Suppose I'm going on the A to B. Okay, this one is different from going from B to A.
Yeah,
Then you
Yes.
have two way, right? Two different way.
Directed line. These are
That means
directed line.
AB and BA, right? Then you can do. See here, order is matter. Order is different. Then it will be 2P2.
Like the sir graded assignment question, station 1. How
Yeah.
many?
It can. Okay. So it's clear or not? So similarly for n points, you have NC2 when direction of, you can say segment has no direction. If segment has direction, then in how many ways you can do?
NP2, sir.
NP2, right?
Yes, sir.
So I think I have covered all the topics of V5 and V6, right?
Yes, the topics are covered.
Okay, so anything
Sir,
you
can
want
you
to
take a
ask?
case example?
Which one?
Any question which includes case. For example, question number 5, graded assignment 6. It has to be solved with cases.
Part 1, right?
Yeah, part 1. Suman has to choose clothes. Fourth one, sir. Fourth one. In your fourth one, sir. Fourth.
Okay, yeah, everyone has different. So,
sir, can you also tell us
yeah, sir. In this type of question, in which we have to consider cases, like I have done 99% errors.
Okay, but see, if you see in the question, it was also mentioned every cloth is to be used at only one day, right?
One day.
That means one cloth can be used at one, right?
Yes, sir. Repetition is not allowed.
Repetition is not allowed. If you see M cloths of different type, can say C1 up to CM, you have to use at different day, right? But due to some reason, first cloth, that is C1, must be used either at D minus M these 2 days, right? Then for the first cloth, how many ways you have?
2 ways.
2 ways, sir.
Right? See, just try to focus on the question. Everything is mentioned in the question, but just you have to be, clear that 2 ways for the first cloth, right? For the second cloth, how many ways you have?
2 ways, sir.
2 ways, sir.
Why? It should be 3.
Okay. It's 3 ways. Yeah.
Okay, it should be 3, right?
Right, sir.
No, you are wrong.
Two ways, sir. 2 ways, sir.
2 ways, because if you see
2 ways, because one is used at C1.
Yes, because DM minus 1 or at DM minus 2 and DM, right? You have 3 options. But C1 cloth is used either at the DM minus 1, I mean, any of one, right? Then you have 2U.
Any of one.
Any one of the DM minus 1 or DM minus 2. But you suppose C1 is used at the DM minus 1 day, right? Then for using the C2 cloth, you have 2 ways. Either you can do use on the DM minus 2 way or 2 day or DM. That is right. Okay. So there is only 2 conditions for the first cloth and for the second cloth. Now that means 2 cloth is used at the 2 way, 2 day, right?
Right, sir.
Now for the third cloth, in how many ways you can use?
Out of M days, sir, we will subtract 2 days.
M minus to subtract.
M minus 2, right? Because 2 cloth is already used at the 2 days. For the fourth cloth, in how many ways? I mean, how many days you are?
Minus 3 days.
M minus 3 days.
For the fourth, M minus 3. For the fifth,
M minus 5.
Similarly, for the one way for the last cloth.
Right, sir.
So just multiply. Why multiply? Because you have to, every cloth is used at only one day, right?
Right, sir.
Is it clear now?
Yes, sir.
Yes, sir. We have to multiply.
Yes.
Sir, I have a question, sir.
Yes, please.
Yeah, sir. For example, if a hall has a 12 gate, right? So in how many ways the man enter into the hall and throughout gate come out from that gate, same gate, sir?
Come out the?
Sir, a man has a 12 gates, okay? In how many ways, sir, can a man enter the hall through one gate and come out through a different gate, sir?
Okay, so there are 2 gates, right?
2 gates, right?
Yes.
This is suppose enter gate. This is for the gate for exit, right? How many people you have?
Sir, 12. No, we don't have a people. We have a gate, 2 gate, 12. I mean 12 gates.
12 gates.
Yeah, it's a hall. Hall has a 12 gates.
Okay. And there should be like some gates for entrance, some gates for exit.
This only with this much of questions given, sir. Question given, sir.
Where question?
Sir, graded assignment question.
We can enter from any gate, and we can enter from any gate.
This much question
In which
given,
assignment?
No, it's not assignment. It's just I have done. I'm doing combination from different books, sir.
No. This question is there. I think it's in activity or practice or graded. It is there because I have faced question. This question is there. I'm searching. I think it is in practice assignment.
This was in one solve with a session. Sir has solved.
See, suppose there are some, I can say like, suppose A gate for entrance, okay? Right? And
yes, sir.
B gate for the
exit,
okay? Right? Then you are saying in how many ways a person can enter that hall and exit
through one gate and come out through a different gate.
Okay. So you can tell me
12 into 11 ways, sir. 12 into 11 ways, sir. He can enter from any of the 12 gates, and from which gate he entered, he cannot exit. So he has only 11 options available.
12 P2 basically.
What?
Okay.
Let us visualize first. Let us visualize. Don't interrupt, sir.
Let me finish this one. Okay. Suppose you have A gate for the entrance and B gate for the exit. Okay. And condition is like suppose you can enter from the only one gate and exit from the one gate only. Okay. Then in how many ways, whatever you can say, what will be the, you can say, cardinality type of things. So what will be the total number of ways? A and B?
Yes.
Because any person can enter through any of the suppose A is some number. Suppose A is the 10 and B is again 12. Okay. Then any person can enter any of the 10 gates. Right or not?
Right, sir.
Yes, sir.
Right?
Yes.
And he has to exit also. So he can exit from any of the 12 gates.
Right.
Yes, sir.
Then how many total?
120.
120.
That's it.
So, but entry and exit is not a simultaneous action, right?
Exit and entry?
Yeah.
No. See, what is the question?
He can
suppose
make
question
entry
is
through one gate and exit through other.
Okay. See.
He cannot use the same gate for entry.
Sorry?
He cannot use same gate as entry gate. It means he is entered from one gate. He cannot use for exit.
See, what is this question? I explained. There is 10 gates for entrance and 12 gates for exit. These are the 10 different gates. These are the 12 different gates for exit.
Okay.
Okay.
Okay, sir. Okay. So a person which has entered has to exit. So we are multiplying.
So it's clear to everyone?
Clear, sir.
Yes.
So can you please explain question number 2 of the graded assignment 6, the train Chennai to Bangalore? In this, the third question, but in solution, the second question. Yeah.
13
Chennai
stops
to
between Chennai and Assam.
Okay. So what is your doubt?
Sir, I could not understand the last part, irrespective of the direction of travel. So I got confused whether to use permutation or combination.
No. See, irrespective of the direction means you can travel from any one station to another station. It's not mentioned like Chennai to, you have to go from Chennai to Assam, direction from Chennai to Assam only.
So Chennai to Assam and Assam to Chennai are two different cases or same?
Okay, you tell me. You are going to Chennai to Assam, right?
Yeah, we need one ticket for that, Chennai to Assam.
And Assam to Chennai?
another ticket. Logically, it should be like that, but I got confused with irrespective direction of travel. I thought Chennai to Assam and Assam to Chennai, only one case should be considered.
Okay. No, that is not a meaning of that. The irrespective direction meaning of that is means you can move, you can travel from any one station to another station. Okay.
Okay, sir.
Anybody else? Any doubt? Then
Sir, I have a small request.
Yes, please.
Sir, please take one session with more complicated problem solve with us like type.
Yeah, sir.
Okay,
that would be my request also. Just take complex question, as complex as you can take, as long as how many cases we should write. Just
Sir,
confuse us,
confuse
us as much as you can.
Sir, like we see
Okay.
graded assignment and practice assignment.
Yes, sir.
Okay, we'll try.
Plus one,
We'll
sir.
try.
I'm also
We'll
agree.
We'll try. No worry about it.
Sir, I have one specific doubt. Actually,
Yes, please.
in that
Sorry?
board, see, in student manual, he has told clearly that the Week-quiz 2 will be content from week 5 to 8. But today somebody has asked, you have replied it is from week 1 to week 8.
Yeah, see, syllabus for quiz 2 will be week 1 to week 8, but majority, major proportion will be from week 5 to week 8.
Oh.
Okay.
Oh.
Okay, then anybody else have any doubt? Otherwise, we can.
I have one question. Can you help
Yes.
me with that?
Yes, please. Yes.
Assignment, graded assignment, 6 question 4. 7 in how many ways can he select 7 group of friends from 14 friends? So A and B will not party together.
Okay, have you gone through the syllabus?
Solution. Okay.
Okay.
And is equal to 10
Just read the. Just read the statements which. Okay. What is total number of ways in which you can invite his friend to the party without any condition?
Without any condition, it will be 14C2.
Right. Suppose with the condition that 2 of his friends will attend the party. Then two friends will be minus.
So if 2 friends say will not attend, if 2 friends will not attend the party together, so if A comes, B will not come. B comes, A will not come. That's the case, right?
See, if the 2 of his friends say A and B will not attend the party.
Party together.
Okay.
Yes.
Together. Be focused on the together. If A is not
Okay.
attending, that means B will not attend.
B will
not attend. So suppose.
No. I understood the question differently. If A does not attend, B will attend.
No. Suppose in how many ways you had an example of 14, right?
Yes, but if say A and B does not attend together, that means they can attend separately, right?
Not attend. Okay. Let me.
But that my question is here is this: if it says if 2 of his friends A and B will not attend the party together, fine, I get it. A and B will not come together. A can come separately. B can come separately.
Okay. See, in how he can select the M friends out of group of N friends. Okay. First, how many friends you have to select it?
2 friends. 2 people.
2 friends
No. Says 7 friends. He has to pick 7 friends.
Out of
14. So 14C, 7 will be the total number of
ways. Okay.
Total number of ways. Okay.
Okay. Just tell me number of ways in which you can. That person can invite his friends so that 2 of his friends will attend the party.
It will be 2 of his friends will attend the party will be so 2 is guaranteed. Then he has to invite 5 people. He has to invite 5 people from the remaining 12. So 12C5. 12C5.
So this is the way for invite those 2 people, right?
Okay. But my question here is this thing, right? When so if they do not see, it says the 2 people will not attend the party together, correct? That means A can come, B will not come.
Okay.
A or B, A can come, B will not come. If B comes, A will not come. So 2 possible scenarios here. I see here.
There is one more case you are forgetting. both A and B will not come.
Yes.
Both A and B will not come. That
then
is
the
there.
answer come. Answer will. You will get the answer.
Okay. So according to you, what will be the number of A's?
So if
14
A comes 14C7,
and again
it will be then 12C5.
12C5 minus or plus?
It should be minus.
Again.
Then it will be so it will be 13C 13C6.
13C6 what?
Yeah, because let's say A is I complete. See, I think I misunderstood the question. Now looking at the solution, I think I get it. So when I read the question as A and B will not come together, okay, that means
then you got confused like
13C6 plus 13C6.
Yeah, you confused between there are two cases only. That's the visualization problem. I also faced that.
No, not it.
Yes, because these are
because the third case is hidden. What if the both are not coming into the party, A and B?
No, but that is not. That is see that see the only condition given is A and B will not attend the party together.
See,
third case we have to visualize.
Yeah, we can exclude
Third
both.
case we have to visualize, Shiva. That's the issue. That's the issue. We have to practice that. We have to visualize that.
Yes.
No, when I read the question right, I assume that A and B will not attend together. That means A comes, B does not come. B comes, A does not come. I never assumed I never assumed any scenario from the question.
Okay, so you are saying, okay, A not come, right?
A not come. A not comes, B will come.
B will come, okay?
Yeah. So
then
B will come.
Then
B will come means 13C6, correct?
This 13C6 is correct, or it should be another?
Because B is there, we have to select 6 people from the remaining. No, it should be 12C6. A is not coming, so it should be 12C6.
12 will be when those two are fixed, right?
Yes, those two are fixed, right?
Only one is fixed. You are saying
no,
only
one is fixed. He's coming. A is fixed. He's coming, and B is fixed. He's not coming.
Yes, sir. 12.
A is fixed. A is fixed. He's coming. B is fixed. He's not coming.
Yes, sir. We are inviting A but not B.
Yeah. So the question says that A and B should not come together. That's all. It does not say any scenario where A comes, B does not come, B comes, A does not. That scenario is right. 12C6 plus 12C6.
Let's solve this one. You will get
you can visualize this question this way. We can invite A but not B. We can invite B but not A. We can also exclude both A and B. We do not invite any one of them.
So then it should be 12C6 plus 12C6 plus 12.
One second. Let's take a 4C. Let's take a 5C3 minus 5.
What's the number, sir? What's the number?
Suppose I want to invite 2 friends. 3 friends for the party in which 2
out of
out of 5. Okay, so 5C3, and for the 2 it will be what? 3C2, right? If 2 are coming, right?
Yes.
Then what will be this? 5 factorial 3 factorial 2 minus 3 factorial 2 factorial 1 factorial, right? It will be 5 into 4 into 3 factorial 3 factorial. Your 2 will be cancelled out by 2. This will be 3. This will be 10 minus. It will become 3. That is, you have 7 days, right?
Yes.
Now, let's take your approach. What you are saying? 4C3 plus 4C3.
4C3,
right?
Yes.
Then what will be this? 4 factorial 3 factorial into 1 factorial. Okay.
Yeah.
That is the 4.
Yeah.
4 plus 8. You are counting the 1 extra. 1 extra is 1. You are saying here A is coming and B is not
coming. Yeah.
B is coming.
A is not coming.
A is not. Then
see this when A and B do not come together, this is what actually means, right?
Sir,
So
here we will not take 4C3. Here we will take 3C3. A is coming, but B is not coming. So we will exclude the case of B, and A is fixed 1C1, and the remaining 3 will be chosen out of 3.
3 factorial. It will be 3 factorial.
Yes, sir. 3C3 plus 3C3. When B is coming and
one second. If got it. Suppose A is coming, okay, A is fixed, right?
A is fixed. Yeah.
Then
B is eliminated.
B is eliminated, right?
Yes,
you are saying. Then in how many ways you can invite your friends?
We can choose
12C6.
No. I'm saying let's take this 5 example. That's
okay.
So that
5 people, right?
Okay.
Yeah, 5 people, right? So
Okay.
then the next cases it will be you have to pick 2 more people from the remaining 3.
Remaining 3?
Yeah, 5. There are totally 5 people. 2 people are already eliminated. Okay. One is coming, one is not coming. So we have to pick 2 more people. Okay, from the remaining 3. So 3C2.
You are saying 3C2, right?
Yes.
Now, again you are saying.
Then in the other reverse scenario,
coming,
B is coming. Again, it will be 3C2.
Right?
Yeah. And you have to add both the scenarios, right? 3C2 plus 3C2.
One case it will be there or not?
Oh, this case I didn't. Okay. This case will also be there.
Okay. So it's clear now. Just read this one. Read.
Okay.
Read this statement. You will get y total minus when both of the friends will come.
Okay.
Sir, but in that question we are excluding one case, sir. Please go to the whiteboard, sir.
Okay.
Yes, sir. 3C2. Where had you written 3C2?
I think in the next slide.
In the next slide, sir. Yes, sir. A and B, and a third case, sir, when we are not inviting any one of them because they don't have to attend the party together.
That will be 3 from 3. That will be 3C3, right?
3, 1. Then 3 plus 3 plus 1, 7. Answer will be the same.
Okay.
Yes, that's why I said.
Yes, sir. Yes, sir.
This is the same 7, or I can invite how many ways? 5C3 total. Okay. Minus when A and B will come 4C2.
Yes, sir. Yes, sir. Both will give the same result.
Okay. No, sorry, 3C2. Because A and B come, right?
Okay.
You are getting my point or not?
Yes,
5C3 minus 3C2. Then this one is the 7. See, initially I have computed this quantity. This is the 7, right? See, there is 2 approaches. One approach is total ways in which you can invite your friends, right? Minus when both of them will come. You know both of them will come. That means you have to choose from these 2. I mean, out of 3. Out of 5 people, okay, right? You can invite how many? 3, right? But you know A and B are coming.
Yes, sir. A and B are coming. Then will we, sir? We will invite 1 people out of remaining 3 now.
1 second.
Okay.
No, 1 second.
I think I missed the scenario where both of them are not invited.
Yeah.
Because I did the math just now. My answer was, in the graded question, my answer was, I did 924 plus 924 924, which is like A comes, B does not come. B comes, A does not come. But A and B does not come is
See. It will be 3C, 1, right?
Yeah.
Yes, sir.
Then what is this quantity? 10?
10.
Minus?
3.
This
7.
is the 7, right? Now, this is the one approach. Another approach is what? Right? Or?
C2 plus 3C3. Yes, sir. 1, 3 plus 3 plus 4.
Clear?
Yes, sir. Clear.
It's clear?
Clear, sir.
Okay. Okay.
Yes, sir. I missed one scenario.
Now,
Completely my fault.
See, you got the concept between these two, right?
Yes. I got it.
Yeah. Initially, it was mistake. It would be 3C1 actually.
I just redid the math and added 12C7 to my answer. I had given 1848 as the answer, and then I added 792, which is 12C7. So I got it. I did 12C6 plus 12C6 plus one scenario 12C7. I didn't do that. I assumed one person will come and the other person will not come. So those are the two scenarios I did.
No, one scenario will be when both of them will not.
Both of them will not happen. Okay.
Sorry.
Sorry for wasting the time. Sorry, sir.
No, not wasting time. See, things should be clear to you. That is our standard.
Okay. Thank you so much, sir.
Thank you, sir.
Then if you
sir, try to get that solved with a session, please.
Yes, sir. Yes,
okay. We'll try.
Take as much complex question as you can as per our levels.
Okay. No.
Please,
yes, sir.
Arrange
please,
one more
humble
session,
request, sir.
Yes, sir. Please arrange one more session regarding Week-5 and Week-6.
Okay.
Yes, sir. Solve with a session because we are not from maths background and we are facing more issues.
Yes, the same.
Visualization
no worry about that. We
just
will do.
take as many cases question as you can. We have to make cases. Please, sir.
Yeah. We'll try to do.
I also agree, sir, because in long term, sir, in many of the entrance examinations, permutation and combination is the very key topic.
Yes. Okay, no worry about that. We'll try to do that. There is then you will get announcement for the sale. Okay. Okay.
Thank you, sir.
Thank you, everyone.
Thank you.
I was able to clear all the concepts.
Yes, sir.
Yes, sir.
Yes, sir. Thank you.
Yes, sir.
Thank you. Bye.
Good night,
Thank you, sir.
Thank you.
Thank you, sir.